Hey, we're ready. Oh, this is so good. Thank you for coming. I love the fact that you're organised in groups by T-shirt. I'm not sure he managed that. It's like being at a football pitch. It's great. Thank you. Yeah, and also, if I can't see your face, I know that you're on your phone, so I'll be taking names. Right. So hopefully you're here to hear this talk. It's about cybercrime and what's going on, what's happening in the world to try and fix it, and some stuff about what you can do. By the very nature, it's a big subject. So I've got 40 minutes to explain this to you, and maybe a bit of time for questions. If I don't touch on something in enough detail for you, can find me at the Stone-Type booth through the week, or I am doing a BOF later on today about S-bombs. Come and talk about come there, because we'll take that conversation wherever it goes. So if you've got stuff that you're interested in, you're knowing more, then do come and talk. So let's start. What do you think when somebody says to you, cybercrime? What do you think? As a developer, what do you think? Well, often people go, oh yeah, it's those guys, they just hack things. It's like somebody walking down a street and trying out the handle on a car and, can they get in? It's just random opportunists. Or maybe it's more like this in your head. Maybe if you've watched movies like Ocean's 11 and the others, where there's really complicated heist things, and it's really complicated and it's stressful and it goes wrong and they succeed and it's wonderful, right? And it's overly complicated. And so maybe you think like one of those. Maybe you think it's drive-by, happens randomly, or maybe you think it's something more sophisticated. But even so, they're so complicated, they're never going to happen to me. The other thing when I talk to developers is this weird thing, which is that because we can't see the bad guys, we often assume they're not here. As human beings, we're comfortable with the idea that if bad things are happening, but it's far away, it doesn't affect us. But if it's close by, then it does. And we have this thing that if it's happening on the internet, it's always far away. And when we hear names like Russia and China and Iraq and all these people, it's oh yeah, a long way away. Right? So it doesn't mean anything to us. Right? And of course, that's not true. The other thing that we think as developers, and since I talk to developers a lot about this comes up a lot. There's two things. One is why is it my problem? As a developer, why should I care about cybercrime and security? And then of course there's also actually I do care about it, I don't really know what to do. And totally legitimate, right? As an industry, we have spent a lot of time tuning our processes, and security tends to get taken out, and you probably go, I don't do security, somebody else does security. Right? So this talk is about level setting. So I'm going to explain to you what the bad guys do, very high level, what's going on. Then we'll look at what's actually happening in the world to try and address this stuff, because it's all early days, but there is stuff happening. And then I'm going to touch at the end about activities that you can get involved in, things that you should start to learn. And hopefully you'll walk out of there a lot wiser, probably more scared. So my name is Steve Poole. I used to work for IBM. I used to work for Red Hat. And in fact, the last time I was here, 2019, I think I worked for IBM. And I did a cybersecurity talk then, I remember. But now I work for Sonotype. With the people who run Maven Central, and you've probably heard of Nexus and stuff like that, and it's all about secure supply chains. So I'm working for them because I get to do the thing that I care about, is talks like this, helping you understand all about security and from this point of view and what you can do about it. By the way, I'm wearing a T-shirt, the only one of its kind, which has one version of a potential Maven logo on the front, Maven Central logo, and one on the back. We are looking, because Maven Central doesn't have a logo. So if you're interested in helping us, then, and you've got an idea or you've got an image, then do me a favor, tweet it and put #Maven Central on it, and maybe we'll take it, because we're looking at what we can do, because Maven Central doesn't have a logo, and it should. Right, so let's talk about cybercrime. What's happening? So it used to be, and it still is, that people hack systems for the fun of it and do silly things, right? That continues. That's never going to go away because there are 15-year-olds who are in their bedroom hacking, the FBI and traffic lights and things like that. And that's because it's easy, right? It's just easy. But that's not the big thing. This thing, crime is worth money. So in 2016, not that long ago really, cybercrime cost us, or made the bad guys, $415 billion. Billion dollars. It was the same as the illicit drug trade at that point. And you know all about the illicit drug trade. You've seen all the movies. You've heard about stories about people weighing money by weight, right? And all that, and all those movies, and that's just the drug trade. And the cybercrime was the same, right? So for your $415 billion in 2016, how many of these massive aircraft carriers do you think you could buy? Well, you can do the math, right? You could buy 50. That's how much money these bad guys were making. 50. Unfortunately, it's raised a little bit. So it's been about 56% growth year on year since then. You can see the drug trade has gone up a little bit, but basically cybercrime has continued, and it's now worth about $6 trillion. So $415 billion in 2016, got you 50 of those. $6 trillion gets you 620. Okay, so now we're into silly money, right? Where do you park 620 aircraft carriers? I mean, it's bonkers, right? But let me make it even worse. Let me put this in real context. If you had all that money and you were a country, where would you be in the ranking of country by GDP? At the bottom? At the top? Well, it turns out, according to Wikipedia, that if cybercrime at the moment was a country, by GDP, it would be the third largest in the world. So just let that sink in. There's all that money coming in. You can imagine what you can do with all that sorts of money. You can do lots of good things. Oh no, lots of bad things, right? And it hasn't stopped. If you carry on these predictions, then by 2024, 2025, it'll be the number one. $20 trillion or something. I mean, it's bonkers. Oh, guess what? It's not even about the money. It's much more scary than that. The money is the easy bit. So you still have all these people out there who are hacking your systems, who are still trying to ransom your data. There are all these botnets. They're all there, right? They're trying to steal your CPU to do crypto mining, you name it. All that stuff happens, continues, not going away. And then there's a massive surge to hack open source projects, which we'll talk about. There's fake packages being registered in Node repos or Python repos by botnets. Massive stuff turning up. There are people, they're compromising the build systems that you use on open source projects to get stuff in there, right? And they're doing it for this new reason. Long-term control and stealth. Or to put it a different way, cyber warfare. What has happened, literally over the period of the pandemic, has it become obvious of something that was happening has now become visible. We're now talking about cyber warfare. So people are hacking systems for money, and they're doing ransomware for money, they're doing all this stuff, but they're also doing it as a way to get into systems. And I'll talk about that in a sec, but we're talking professional people hired not just to hack in to get money, but to do something much more stealthy because they want to get into systems and control them. And very targeted, very persistent. And everybody in the world, as in every nation state you can think of, and probably other groups, have cottoned on to the fact that this is a valuable and necessary activity, right? And it's just visible. It's been around for ages. We've all heard about, you've seen it in the press. The FBI, the CIA, you name it. There's always been some level of that. But now it has become personal. It's now mainstream. It is a major activity that is part of this world that we live in. And they're targeting you as individuals. They're targeting the groups that you work with. They're targeting the organizations you work with. They're targeting your country. Right? They're trying to get in for reasons, which we'll come to. And it's all about this new term. Well, it's not really new, but you probably wouldn't have heard about it. And it's called supply chain attacks. Right? The idea is to get into the supply chain. And the supply chain attacks, the number of supply chain attacks, which you can, and because you can classify the types of attack, and over the last couple of years, it's just skyrocketed. It's 700% increase year on year of people attacking supply chains. It's just enormous. So what they're doing is to get into your infrastructure. So this is get into as a country, attacking another country, can I get into your systems, ideally quietly, so that you don't know I'm there, so that when I need to, I can do bad things. So can I get into your transport systems? Can I get into your banking systems? Can I get into your supermarkets? Can I get into your train stations systems? You name it. Anywhere that is a part of your economy is a target because they can get in there and control it. And then when the time comes, kill it, manipulate it, terminate it. And it's little things. It can be, all I have to do is get into the system, your system, because you're all part of a supply chain. We all provide something to somebody. And if I can get into your systems and I can change the addresses, what happens if I get in and I look at your zip code or postcode and I change them, or I swap addresses, and I cause chaos, little bit of chaos. And that's what we're beginning to see now. And that this is cyber warfare not for some big conflict, but as a current ongoing activity. Can I get into your systems and compromise them? Can I affect your economy? Can I influence you? Right? And this stuff goes on. You've heard about it, you've read about it, but now it is mainstream. It is the next wave of stuff that's happening. This is the reality that we have to work through. We have to figure out what that means for us and how we're going to defend against it. Because everybody's connected to everybody. There's no distance now. They're next door. Right? The only distance is how long's the piece of fiber or how long is the piece of copper, but they're still next door to you. Right? And of course, that means that we have a new world and we're beginning to understand the complexities. We've lived for many years with the idea that security is somebody else's responsibility, and we've got away with it because we haven't really had anywhere like this scale of bad actors. But now we have a lot of bad actors and the numbers are growing, and we are easy pickings, and we have to fix that. Right. Now, as I said, the only thing between you and the bad guys is software. Think about the fact that you're here. Think how much software was involved in getting you here. And think what would happen if any piece of that software, whether it was the scanners or the ticket machine on the tram or your flights or just the fact that you were trying to figure out on your phone where the place was, you use software in every aspect of your day. And think what happens if any part of that software gets compromised. Because this is what's happening. We have so many instances attacking software in cars, obviously routers and Wi-Fi, printer devices, you name it. Everything is being attacked But because of this expectation of doing it in a way so that it is stealthy for this manipulation, it's a new level. It's not people taking over your printer and printing out, I don't know, rude pictures, whatever. And that's, no, I get into your printer so that I can steal the data that you print. I get into your scanner because I can steal the data you scan. I get into your email systems, you name it. From top to bottom, we have so many instances of people trying to get into something, right? And where it used to be that these bad guys would wait until these vulnerabilities turned up, because it's all about software vulnerabilities, it's about weaknesses in design, it's poor coding, not necessarily intentionally, but it's all about vulnerabilities. These bad guys would wait, and they'd find them. They'd have some researchers, of course, but it's not fast enough now, so now they're making their own. So I won't go through the terms in too much detail, but there are different types of attack that you can classify, and they're all about getting into the code and the build systems that you use, getting into the open source projects that you use, you consume, getting into their build systems, getting into your build systems, confusing you, finding out the names of internal packages that you use inside your company and getting them published on public repos, so that when you do a build, it doesn't find the local private version, it finds the public version, and it's got bad code in it. They're doing all sorts of things in these sorts of categories to get into you. And the time you have between these vulnerabilities being reported and you fixing them is closing. We used to talk about 0 days, which was that horrible thing when a major vulnerability was reported and it could be exploitable immediately. You have no time to fix it, 0 days. This chart shows you how long we've had. Way back in 2006, we had 45 days from vulnerability being reported, even a big, scary one, before it was being exploited. And by the time it got down for Log4j, well, it's gone. Right? There is no time. When you get a vulnerability reported, it's already being exploited, because they are vehicles for getting in. We have evidence, multiple evidence of researchers finding these vulnerabilities and not reporting them because they are being paid staggering amounts of money to suppress it, because it becomes a vector for cyber warfare. Right. China now requires any disclosure that's found by a researcher to be reported to them first. Okay? And you can imagine that the more severe the vulnerability, the more useful it is, the easier it is to exploit, the more power it is, the less likely it is for anybody to report it, because it is worth money. It is worth influence. It is worth power. And so if you're an unscrupulous individual and you want to make some money, then become a bug finder, because there's loads of tools to help you do it. So we're into this new world. We have cyber warfare as a mainstream, and we're into this world where those vulnerabilities that turn up on your door are already being exploited. Is that scary? Scares me. Oh, One more thing. Who went to the keynote this morning and did watch the thing about the AI? Yeah, okay. You think they're not using AI? AI is already being used. The things we saw this morning about generating what look like human responses, they're already being used. There are AI techniques out there to figure out how to work past spam filters, for instance. But also there's a whole activity about using AI to convince systems that there's a human being, or to analyze and look for weaknesses. It is already mainstream. It is happening. Okay, so it's bad enough that we have to do something about it. And if we don't do something about it, what happens to us as individuals? What happens to our countries? What happens to our economies? We have to deal with it. And so the way that we started was the way you'd expect. So in 2021, this man, Joe Biden, signed an executive order. And his executive order was basically, hey, you guys, you go fix it. And what he did, or rather what the White House did, was to bring together many companies who were part of the solution. So they got the big names. I mean, even Sonotype sent some people, Google, IBM, you name it, Amazon, everybody got together and said, how do we fix this? What are the practical steps? And so a plan is slowly emerging. Right? Now, the executive order has the usual sort of big stick in it. The first thing it does, it says, hey, we recognize that this is a real problem and we need to do something about it. And then it talks about how people are going to work together. Right? And then it says, and this is where the big stick comes in, we're going to say that by about 2024, you won't be able to sell software to the US government unless you pass a whole bunch of special rules, guides, whatever, which are TBD. Right? And the challenge for all of us is that because we all use everybody else's software, we all rely on open source software. If by saying you can't provide software to a government organization, and believe me, this is just the first, this is the US is leading, but everybody's going to do this. Once you get in a situation where you can't sell software to a government without being clean and having all these certificates, when you start looking at it, you realize that 90% of the software that is in your application is probably open source. So actually, you only have control of 10%. So we're beginning to realize that this requirement on us isn't just the code that you write, it's all the code that you consume. Right? So it's going to have a profound effect on how we produce software. We're pretty much day one on this, but it's beginning to percolate around. So if you look in more detail about what's being asked of us, there's some obvious things, and there's some common words coming up. So there's a thing like an SBOM, software bill of materials. I'll talk about that in a sec. But you look at the other things. So they want an automatic supply chain process, right? Evidence of software integrity, demonstrations, audits, has a vulnerability process, an automatic vulnerability process, has a vulnerability disclosure process, so that you can show that if somebody finds a vulnerability, you know how to deal with it, right? Evidence, audits, demonstrations, controls. These are the requirements that are being placed upon us. A lot of this, and it's not written down here, but a lot of this points to the idea that there will be no human beings involved in software production. Apart from the person who presses the button to build something, every single step from production to packaging to deployment, because this also applies to cloud services, it's not just packaged binaries, but there will be no human beings, because human beings have flaws, can be corrupted. So that's where we're heading, towards this much more controlled, much more structured way of creating software with, if everybody gets their way, a lot more reporting and control, right? So think about the build systems you have, and maybe they're not quite ready. So what are we doing? So that's the government's response, which is big stick. And okay, it's done with us helping define what those big sticks look like, right? But there are some things that as a community, and I mean worldwide community, because this is not a Java story. This is an everybody story, right? Java has some benefits in the way it's designed that makes it slightly safer, but overall this is an everybody's problem. All programming languages, everybody's involved in this, right? So I'm going to talk you through these four things. So we're going to talk about the supply chain and what that means, how we actually secure one. I'm going to talk about what we're doing to understand how open source projects are vulnerable and why they're vulnerable. And then what's on the automation side. And then finally, there's a whole thing about, well, we should start to learn a bit more. I'm going to mix and match this, so it's not going to be exactly in this order. Right. So let's start. I said it wasn't Java, but let's start with Java. You know this is going to come up. I bet everybody's going, he's going to put a chart up and it's going to have these words on it. Yeah, okay. Who remembers 10th of December? Log4j. Okay. How many people spent effort that they weren't expecting dealing with it? Yes. Okay. I have to say it's my fault because on the 9th of December, I'm talking to a cyber journalist that works for us and said, you're always giving me Python and JavaScript things. Why can't you give me a Java, big juicy Java thing? And he went, da-da, thank you very much. Yes. Right. We have this thing. It looks like it's the worst vulnerability ever in the ones that we know, because obviously there may be some really bad ones that nobody's reported. It is the one most used, one of the ones most used by threat actors. I mean, you know, the Chinese are ones, I have no idea how they know this, right? But as you can imagine, security groups do have relationships with bad groups. You know, it's part of the process. And the thing I want to show you is not, excuse me, I don't want to beat you over the head because you all worked hard on this. Things came through, you fixed them, right? But it turns out that Log4j is a really good example of the things that we don't do well. So I said before, Sonatype runs Maven Central. And as part of that thing that we offer, we keep track of what's being downloaded, and we look at platforms and profiles and that sort of stuff. This is a download page. This is, in fact, this morning, and you can go to sonatype.com and you can find this. So the two things to note is the big number on the left, the 51 million downloads, and then the little one, the 33%. That 33% says that of all the downloads of Log4j from Maven Central in the last 24 hours, i.e. from about now to this time yesterday, 33%, 12,000, were vulnerable versions. How many people here think they fixed the problem? We all think we fixed the problem. Anybody want to fess up and go, no, I'm not sure we did? Well, yeah. But you can see, somewhere, something is going wrong. And I can point you at multiple reasons why it might go wrong. The first one is we've discovered that, and you probably knew this, but the scanning tools that you rely on, they're not equal. Some are good, some are bad. And it isn't just a matter of technologies. You know, I have the best technical scanning tool. It's also about who has access to the best data. And it's those combinations. And those, can this tool find a class in a particular package in a jar file? Yeah. Can it find it in a fat jar? Maybe. What happens if it's been renamed? Can it spot Log4j if it's been renamed? Don't know. You have all these questions about how good the scanning tools are, and then having found the binaries, do you have the data to tell you that's good or bad? And depending on which services you're using from whom, you'll get good answers and you'll get bad answers, right? We don't check them. In fact, nobody checks them. Nobody ever spends time and effort to look at the tools that we use for security scanning, scanning our dependencies, to work out if they're any good. Because almost always, your company just wants a tick. Right? No false positives, please, tick. And that's not good enough, right? Because there's so many ways that you can let this happen. And of course, the other reason that this might happen is that you don't care. Because, oh no, we don't use Log4j. It's in our class path. We don't use it. But of course, if you're savvy, you understand that if it's in the class path, you're vulnerable because there are many ways to get code into your system or make your system behave ways that you weren't expecting that can access those code. Right? So it's understanding of how systems work and why you're not doing it correctly is an imperative for us all to learn how this stuff works. So the first thing to look at now is that we're using this, we scan stuff, and it depends on how good that technology is. So the first thing that's on the table is switching that around. So we are going to start seeing, and in fact it's already here, switching from scanning tools that try to work out what you've got towards systems which will tell you what you've got. So you will see SBOM, software bill of materials, and it is literally that. It is a list of contents, the binaries, the versions, digital signatures. Because if I give you a list, or you give me a list of all the things that you have in your system, I can scan it because I have complete accuracy. I'm not having to discover it because your bill processor spitted it out. Now, associated with having that sort of list, there's also a couple of other things. One is you have to be able to digitally sign this. There's a whole bunch of signatures involved in making this happen, and they need to be put somewhere where people can consume them. And obviously they need to be a trusted website and things like that. So there's some stuff in that space. And also, which we haven't got to yet, but we're moving towards that space, is that you still need to have scanning tools because SBOMs tell you what the package names are or what the dependency trees are, but it may be that there's still stuff hidden away in one of those dependencies that is not meant to be there. It's been squished together. So you still need to have good tools that can find vulnerable code, but now you can do that on a publishing point rather than you having to run it every time that you get some new code in. So it's starting to move this stuff around. So there are two standards you can go look for in the SBOM space. And I said I'm doing a BOF later on today, so if you want to know more, come along to that. So the two types, CycloneDX and SPDX, they are the ones mentioned by the executive order, but there are a couple around. CycloneDX is designed specifically to do this. It's an XML format. SPDX it's the one you may have seen that did copyrights and licenses. There's a new version of that coming out, version 3, that's being designed specifically to do this SBOM stuff. Right? So SBOMs are going to start off with just being like a POM, and each of the elements that you have in that POM, there may also be a reference out to the SBOM for that dependency, and so on and so on. And eventually, it's possible that will also be in here will be information about how you built it. What compiler did you use? What platform did you run on? And maybe even eventually down to how you triggered the build. What was the build, the parameters you put into the compiler? Because all of those things can have an effect on whether or not you're vulnerable. Right? We're not starting by doing everything, but we're starting by doing the first thing, starting to flip the way that we record the dependencies that you have in a way that can be scanned by scanning tools without having to do this deep dive. Right? The line at the bottom, as you can probably imagine, is that you can go do this now. So there's a CycloneDX plugin. So if you want to see what an SBOM looks like for your binaries, then you can go trigger that and use it now. So Cyanotype put together a visualization tool, which you can go play with. It's called Bomb Doctor, of course. This is obviously a static version of this, but you can navigate around it. And the idea is that we're trying to assess give you information about the quality of the components that you have and allow you to drive down and find where things are going wrong. Because it's surprising how many people don't understand everything that they've got because they put top-level dependencies in their POM or whatever they're using, and they know about that, and then they see everything when they do a Maven build, everything, you get that long list of stuff pulling down. Who checks it, right? Who checks what it does and what's in it? No, nobody does. Now you have an opportunity to start looking at it for real in a reasonably graphical way. So this is, prototype. We're kicking the tires with it. So if you want to try it and let us know what you think, that would be cool. But associated with having an SBOM, what I mentioned, there's another thing that came out, reproducible builds, and SIG stores. So you can, go scan for these things. SIG store is literally what it sounds like. It's a signature store, but it's designed to marry up with SBOMs. And you'll find multiple companies beginning to look at producing their own SIG stores and running them. A safe place to put your signatures. Right? We're going to have one in Maven Central. There'll be others. It's just a natural part of this process. Is that if I give you a guarantee of what's in my product, I need to be able to prove it, and I will want to sign it. But it also turns out that we have to go one step further, and that it's very good that if I say, look, here's an SBOM and here's my signature, that you can check, but they could both have been compromised. So the final step will be that eventually you'll be able to rebuild the source code that you've consumed and prove that the binary that you've produced matches the one that you have been told has a particular SBOM. Now you think about what it will actually take to reproduce any particular set of code and have an identical binary. Right? And apart from things like dates, there are other elements, right? But people are working towards that. And in fact, I'm going to a conference in a couple of weeks, which is all about this subject. Right? And so you can see everybody's beginning to think about what are the consequences. The Eclipse Tamarind builds, the Java ones, they are reproducible. Right? And other people are working towards making that happen. Right, so that's binaries and that's builds, but there's still more to do. I touched on the fact that people are trying to compromise open source projects. Well, yes, they are. Open source projects, because they're run by developers who are in the open source community, people like us, we trust each other, we have a community of trust, and unfortunately we now have hordes of bad guys who are trying to compromise those open source projects. That's getting in, becoming committers, doing bad things, offering support, taking over old ones. There are so many ways that people can get into your project because they're trusted and do bad things. Not necessarily instantly, not necessarily visible. Right? And you can imagine there's an enormous amount of open source out there. I mean, there's billions of packages, millions of packages, and somewhere you'll be using one of them, and they're all potentially targetable. So what you have to ask yourself is, how do you spot those projects? What makes a good project? Because we're now not talking about code, we're now talking about behavior. And there's tools we can apply to help identify that the code maybe has some problems, static analysis tools and things like that, and you'll see those being applied. But what we're looking at is the next level, the human factor. So the Linux Foundation and some of the subgroups and companies are trying to tackle this problem. And one of the ways that we're trying to tackle this problem is figuring out what makes a good open source project. And as you can imagine, that's pejorative. How do I say what's good? People's opinion. So there are some obvious things. So there are two pictures on here. The bottom one is security scorecards, and the one above this is CLO monitor. CLO monitor comes from the CNCF thing. It's pretty straightforward. You think about the basics of security and how you would do behavior. Well, there's one right at the beginning where you say, yes, we do good things. We have a vulnerability reporting program. Right? We understand. We tell you how to report it, so that it's it's not via email or something. We have a security.md file in our GitHub repo that says, here's what we do. And so the first set of things are looking like that, looking at how the product is structured. Are people paying attention? And then it starts to go down into more sophisticated things. Can we look at the behavior? So the next level down, and this isn't the Linux Foundation, Sonotype are looking at this and others are looking at it, but the idea is to go down a level and think about, can you spot unusual behavior? Can we apply techniques? Can we apply AI techniques? Can we apply just data analytic tools? Can we look at a project and say something strange going on? Now, a lot of the time it may be really simple, and it may not even be a security thing. But I suppose you've got a project that does a build a month, and then it does 5 in a row. That may be either a problem of quality, or it may be that some bad guys have gone in and done something. I'm pretty certain that none of you have time to go through that big tree of components on a regular basis and keep checking to see what the open source project looks like. I'm pretty certain, though, that you have in your head some views of what makes a good open source project. I bet you, like me, you've gone to GitHub and looked at something that you might want to use for the first time and go, oh, when was the last release? Oh, look, when was the last Git change? 7 years ago. Maybe I won't touch this one. So we all have some internal views of what makes a good project. What we're trying to do now is figure out whether we can codify that. Excuse me. It's a big job. So the way to start breaking this stuff down is there's a group under the Linux Foundation called the OpenSSF. Anybody heard of the OpenSSF? Oh, I thought you were all going to put your hands up. Okay, good. Go read about the OpenSSF. It is a Linux Foundation subgroup, whatever they're called, community. Has lots of people looking at it. It has good funding, and it is working with other groups. Excuse me. There we go. I brought a cold with me, and I can't get it to leave, but it's almost gone. So the OpenSSF is a Linux Foundation group. It has funding. It is working with other groups like Eclipse and Apache Foundation or whatever. They are looking at ways to apply, discover these sorts of rules. What can we do? Some of it is fluffy. Some of it is very specific. And it's not, when I say Linux here, I think the thing to take away is that when we talk about the Linux Foundation, it's sort of like the obvious place, the most widely spaced group. You can see why governments want to talk to the Linux Foundation because it is what it is. But everything that's coming out of that is for everybody. So they have a bunch of stuff. And they have this mobilization plan. And you can see them. Security, education, well, you can read them out. Right. There's a bunch of stuff they're looking at. Some in detail. Some is going to be specific for certain environments. But you can see things like S-bombs everywhere. There's a specific group whose job is to figure out how to make that happen. Better scanning, as I described. What can we do to find vulnerable software? Because whereas it used to get hidden by accident, now it's getting hidden by design. So we now have a race to try and find the bad code. And when that comes down to us as a Java community, it comes down to things like, what can we do in the JVM to discover this? What can we apply things in frameworks? What we can do? So all this stuff will trickle down. This is sort of like first principles. What could we actually do in general? And of course, it'll get applied to Linux, it'll get applied to Kubernetes and things like that as it trickles down. But you can see there's a lot going on. Okay, so that's what other people are doing. What can you do? Because obviously you'd like to do something. You haven't come here to spend, I don't know, whatever it is, 40 minutes listening to me tell you what other people are doing. What can you do? Well, the first thing is you have to start using these. Oh, sorry. There we go. Right. You have to use your brain. You have to use your eyes. You have to become suspicious. And it's a horrible thing to ask you to do, but that's what you've got to do. We have been completely educated over the years to just accept open source software. And when you talk about vulnerabilities, it's like it's a vulnerability turns up on a piece of open source, and it's always, we go always by mistake. They made a mistake. You look at Log4j, you can look at what happened, and you can say it was not designed. It was never a bad thing. They did what they thought was the right answer. It just had unexpected consequences. Now you have to think that the project that you're consuming, or the project that it's consuming, or the project that that's consuming, may have some nasty stuff that was put there deliberately. So you've got to start thinking about how you protect against that, because you are the first stop, right? You make the first choices as to what software to use, and it may end up that your company has a view of licenses and stuff like that, but you make the first choice. We're going to use this project. We're going to use this framework, right? How do you know that it's the right choice? How would you know? So you need to apply your brain. There's all sorts of things you can think of, and I've got some lists here about what you can do. But you should also think what happens when this executive order finally rolls through. And if you're part of a company that produces software that gets used by a government organization in the US, can you rely on the open source projects that you're using? And not just technically, can they stand up to do this stuff? Because there's a big ask, right? And can they really do that? Can they produce updates? One of the things in the executive order is very fast updates when fixes are required. Can they do that? Is it some one person maintaining a piece of source code? Can he reply to that? You have to start asking these questions. Right. And there are these basic things that you can check for, things I've already said, which you have to put effort into. Right? You can read the words. Do they use the right tools? Do they have billions of committers, which is not a good sign? Do they have unexpected releases? Things that you would go, okay, not sure. Maybe good thing, maybe not. But you have to start generating that sort of mindset, right? And do they often have no path forward? That means occasionally you find people who have a dependency, or they have a software and they're all broken. So if you have the situation where a project that you're relying on has 5 releases and they all have vulnerabilities, that's not a good thing. Are they working to give you a version that's got no vulnerabilities? Sometimes you'll be surprised and you'll see the answer is no. Right. And other things, how's their development process? How do they review code? Do they tell you how they're going to do it? Do they document it? Build processes. Who can trigger the build? So many open source projects, it turns out anybody can trigger the build. Bad guys love that. Are you using GitHub Actions? Are they known GitHub Actions, or are they just handcrafted stuff? GitHub Actions are great because you can find something that somebody else has created and you just use it. Is it any good? Is it safe? Do the open source projects that you're consuming make those choices? Do they think about it? There we go. You have to start stepping up to thinking about this, because this is where we're going. Now, what we, the industry, are trying hard not to put the burden on you, because we need to not do that, because that's not scalable. So we have to start looking at ways of providing measurements. So from Stereotype's point of view, we've been doing that for a long time, and so we're just going to start taking the data that we've got and start making it available. So you will see that Maven Central will gain more capabilities, because we want to give you access to the vulnerability data, which is already there. You can go see what the vulnerability looks like from any particular dependency. But eventually we start adding this stuff, because, well, it's commercially valuable from our point of view, but bigger than that, it makes us all safe, because it makes it easier for you to make the choices that you need to make. Right. So what else should you do? Well, number one, as a developer, who's heard of OWASP? Good answer. Okay, right. You have to go to OWASP. It is the number one thing to do, because Like the OpenSSF, OWASP is becoming a center of some of this thinking. So the obvious thing is you have to start learning all this. You have to learn how to code defensively. You have to learn about AppSec. You have to learn how to design software that is safer. Because much as I talked about vulnerabilities and things like that, there is still all the other problems that are out there that the bad guys can use to get into your systems. So this becomes, hey, you can do this over the holidays. Go start learning this stuff. There is all well documented. You just got to start reading it and applying it, right? It's a skill you have to learn. So you're not going to be good at it for day one, but I said about being suspicious. This is all part of this. How do the bad guys get into my API? How can my API be used badly? I have a happy path. I have an idea of how it will be used. Get some people together and say, well, how could it be abused? And start looking at these things and going, does this, any of these ideas apply? Does this API have, does it have, how does it work? What's its authorization process? How many roles does it have? Are they easily separatable? There's a whole bunch of stuff about how you think about software. And of course, the OWASP has this, is the thing you've probably seen, is the top 10 security risks. That's been updated. So apart from the ordering changing, because obviously it depends, that was 2017, you can see the orders slightly changed. They've added in new categories because we are starting to look at what I've been saying is we need to start educating people about these new actions, like insecure design, right? Software and data integrity failures, server-side request forgeries. This is the new reality. These are the new things that you have to learn about what they are and how you're going to be attacked and what you have to do to defend. Because this is about code. This isn't about API gateways. It isn't about back-end stuff. It's the bit in the middle, the bit that you write. And again, coming back to the Linux Foundation, I'm working with the Linux Foundation on providing you more of the education you need. Because it is a big thing, right? I'm not saying this is not going to be fixed overnight. We are all starting to work towards giving you what you need to do the job that you need to do and try and close this horrible loop of us having no real idea how to protect ourselves, but then having all these bad guys knocking at the door, quite often open doors, to get into our systems. Right. So this summaries here. I have no idea if I'm on time, but we'll stop anyway. Oh, it says time's up. Okay, that was well done. Okay, let me do the last one then. Okay, takeaways. There we go. The way that we produce software is going to change, right? The way that you choose software is going to change, right? It's going to get messy. It's going to get horrible, but everybody is trying to do their best to help make it better. But the number one takeaway is you have to be part of that process and you have to start learning a lot of this yucky stuff because it's on your shoulders to be that first line of defense. And that's it. Thank you very much. If you remember the Maven Central thing, if you wanted to talk to me, SBOM BOF in an hour or two, or come to the booth and ask for me if I'm not there. Thank you. I didn't see that.